Welcome to Chemistry World. Today in this video, let us discuss about coordination compounds and bonding in coordination compounds. To explain the bondings and structure, shape, magnetic nature, sometimes colors are explained by these theories. Just one theory, we cannot explain or we cannot identify the structure of coordination compounds and bonding in coordination compounds. Once again, I'm saying there are five theories are there to explain the bonding in coordination compounds. Coordination compounds means complex compounds. They are formed by combination of two or more different types of simple molecules. So that coordination compounds, actually complex compounds are two types. One is double salt, another one is coordination compounds. Let us discuss that one in another video. Now let us see the bonding, most important topic for NEET exam, JEE mains exam and advanced exam. Compulsory, if they want to give the question from coordination compounds, first they will consider about these theories. They will consider these theories to give the question. So you have to be very perfect in these theories if the question will become from these theories. Once again, I'm saying the theories are used. The theories represent how the bonds are present in coordination compounds. In that, the first theory is Werner's theory. This is the foremost and first theory. And sometimes in someone will say Alfred Werner. This theory was proposed by Alfred Werner, and he is father of coordination compounds because he was the first scientist clearly explained the structure of coordination compounds. So the first theory to explain the bonding in coordination compounds is Werner's theory. After that we have valence bond theory, and after that we have crystal field theory, and then we have John Teller distortion, and last theory to explain the bonding is molecular orbital theory. Now in these theories, today in this video we will discuss about Werner's theory, and let us see how the questions will become from this Werner's theory in a competitive examinations like JEE mains, JEE advanced, and NEET exam, sometimes MSET also, and in board exams also. For all these things, let me start from the beginning of this theory. So these five theories are used for bonding, to explain the bonding in a coordination compounds. Now I'm going to start the first theory, that is called Werner's theory, to explain bonding in a coordination compounds. So first one, let me write Werner's theory. Werner, Werner's theory. Werner's theory. Let me discuss this theory in very simple manner and very short manner, the easy manner to understand this concept, and mostly the question will become from this theory as application, not theory concepts. Questions will become from this theory. Application oriented question will be there in a NEET, mains and JEE advanced. So first, according to this theory, what is that main postulates? If you see, according to this theory, every coordination compound central atom, coordination compounds contains central atom. Usually that central atom is transition element, because the transition elements have the ability to form the complex compounds. Mostly, not only transition elements, inner transition elements also forms, but mostly transition elements form complex compounds, that is especially coordination compounds. So central atom usually a transition metal. Transition metal means D block element. From 1/3 B to 11th B, that is 11th group, 1B. From third group to 11th group, or from third B group to first B group. Second B group, that is 12th group elements, are not transition elements. Of course, they form coordination compounds. They form coordination compounds, but they are not transition elements. Anyhow, let me start the central metal. According to this theory, every central metal atom in the coordination compounds have two types of valencies. According to Werner's theory, we have to consider every central atom in coordination compound has two types of valencies. The first one is primary valency. The first one is primary valency. Primary valency. And the second one is secondary valency. Every transition element has two types of valencies in a coordination compounds. If a transition metal or central metal atom forming coordination compounds, that if it has two types of valencies, that it can exhibit two types of elements valencies, it shows it has the ability to form coordination compounds. So primary valency and secondary valency. Secondary valency. So primary valency means what? It is represents the primary valency nothing but oxidation state of central metal atom. Primary valency is nothing but oxidation state of central atom in the coordination compounds. So oxidation state of central atom is nothing but primary valency of central atom, oxidation state. Usually the metals have positive oxidation states. That's why this valency has positive nature, positive charge. The primary valency has positive charge. Why? Because for metal atoms, transition metal atoms or complex compounds forming metal atoms usually have positive charge. So positive charge. That's why this primary valency is satisfied by it is satisfied by negatively charged ions. Negatively charged ions. The primary valence is nothing but oxidation state. Generally it has positive charge, so that positive charge is satisfied by negatively charged ions. Means the primary valency is satisfied by negatively charged ions. This is positive charge and this is negative charge. That's why this valency is ionizable valency. This valency is ionizable. Ionizable means what? It can convert into ions. If ionization energy, a certain amount of energy is there, if they are dissociated. If the complex compound is dissociated or coordination compound dissociated, those ions which are satisfying primary valency will be ionized. They convert into ions. That's why the primary valency is ionizable valency. If any ions are coming from the coordination compounds, due to the primary valency ions only, that will be formed. That ions will become from primary valency. It is ionizable valency, and here the primary valency is contributed by the ions. That's why this valency do not it do not contribute any shape. The shape of complex compound never depends upon primary valency. It do not contribute anything for the shape of the coordination compounds. The primary valency is ionizable valency. The primary valence has positive oxidation state and it is satisfied by the negatively charged ions, and it is ionizable and do not contribute any shape. For particular, every coordination compound has particular shape. That shape will not be contributed by the primary valency. There is no relation of shape and primary valency because they never contribute any shape. And the last one is it is represented by dotted line. It is represented by dotted lines. Dotted lines. In the textbook or in your notes, if any valency is representing by the dots, that represents primary valency. That valency is ionizable. That do not contribute any shape, and that is satisfied by negatively charged ions. Why? Because the primary valence is nothing but positive oxidation state of central atom. So this is the main points and core points about the primary valency. Without knowing this thing, you cannot get any answer in Werner's theory if the question will become. Damn sure, in coordination compounds, the first and foremost important question will become from this Werner's theory. So this is primary valency of Werner's theory. Let's come to secondary valency of a central atom. Next one, primary valence showing oxidation state of central atom means secondary valency represented by coordination number of central atom. Oxidation state of central atom is represented by primary valency. The coordination number of central atom will be represented by secondary valency. Coordination number means number of coordinate covalent bonds possible for a central atom, means that is possible based on the empty orbitals, the available empty orbitals and required number of empty orbitals and number of dative bonds. Coordination number means what? Number of dative bonds. Dative bonds also known as coordinate covalent bonds. It represents number of dative bonds, nothing but number of coordination bonds. Secondary valency represented by coordination. It represents secondary valency represents coordination number of central atom. Primary valence represents oxidation state of central atom. And this coordination bond, that is dative bond, may be formed by the ligand. So it is satisfied by please try to understand my writing. So that's why I'm saying slowly. The secondary valency is satisfied by ligands. 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 The secondary valency is satisfied by ligands. Primary valency is satisfied by negatively charged ions. Ligand means what? Ligand means electron pair donor. Electron pair donor to central atom. Central atom. Those molecules or ions which are donating electron pair to central atom in the coordination compounds, that molecule or ion is known as ligand. So this ligand may be positively charged or negatively charged or neutral molecule. That may be positive charge, negative charge, neutral molecule. Once again I am saying, so this ligand which are satisfying secondary valency may be positive charge or may be negative charge or may be neutral molecules. These are neutral molecules. Any may be there. The ligand may be positive charged ion, or that ligand may be negatively charged ion, that ligand may be neutral molecule. If it is giving electron pair to a central metal atom, that is ligand, that is satisfying secondary valency. So secondary valency is satisfied by ligands. The charge may be positive, negative, neutral. But in this case, the primary valency is satisfied by only negatively charged ions. That may be ligand or whatever may be simple, non-ligand or ligand. But it will be negatively charged ions. So it is satisfied by only negative. But here it may be positive, or negative or neutral molecule. After that, next point in this case is, next concept is, this valency is non-ionizable, never convert into ions. This valency is non-ionizable, is non-ionizable, never dissociate into ions, non-ionizable, but it is ionizable, is the main point. Primary valence is ionizable, secondary valence is non-ionizable, never gives ions. Once ion or atom or molecule is forming day-2 bond with central atom, that becomes fixed, never come out as the ion. So because it is non-ionizable, it is a covalent bond. It is covalent bond, but it is day-2 bond, coordinate covalent bond. By giving electron pair coordinating with central atom through the covalent bond, so non-ionizable. So it is ionizable. And this secondary valency contributes, here I will write, this is the first point, this is second point, and this is third point, and fourth point for secondary valency I am writing here because there is no space there. So it is, this valency contributes shape. This valency contributes shape. Contributes shape means the shape of coordination compound. The shape of coordination compound mainly depends on secondary valency. The shape depends on secondary valency. If secondary valency is 2, the shape is linear. If secondary valency is 3, shape is trigonal planar. If the secondary valency is 4, the shape may be tetrahedral square planar. If secondary valency is 5, the shape is trigonal bipyramidal. If the secondary valency is 6, the shape is octahedral. If the secondary valency is 7, the shape is a pentagonal bipyramidal, same like that of hybridization concept. Whatever the hybridization concept is there, that is nothing but secondary valency. Because if sp is there linear, sp2 is there trigonal planar, sp3 is there tetrahedral, dsp2 if it is there square planar, sp3d is there trigonal bipyramidal, sp3d2 if it is there octahedral, sp3d3 is there a pentagonal bipyramidal geometry will be there like that. If coordination number is 2, linear shape. If coordination number is 3, trigonal planar shape will be there for the coordination compound. If coordination number is 4, tetrahedral or square planar shape will be there for coordination compounds. If coordination number is 5, trigonal bipyramidal shape will be there. If coordination number is 6, octahedral shape will be there like that. It contributes, secondary valency contributes shape. Secondary valency contributes shape. Primary valency do not contribute any shape. Why? Because just it is satisfied by the ion. Ion may present around opposite ion in any direction. Suppose this is one charged ion, the negative or opposite charged ion may attach here or attach here or attach here or attach here. Anywhere it may be attached. So there is no particular order, particular orientation. Whereas covalent bond is will be particular directional. Coordinate covalent bond is a particular directional. That's why the shape contribution takes place only by secondary valency. Secondary valency coordination number, based on the coordination number. That coordination number may be 2, coordination number 3, coordination number 4, coordination number 5, coordination number 6. Mostly up to 6 coordination number only we have the syllabus. So let me discuss.